So, meine sehr geehrten Damen und Herren, wir kommen zum nächsten Vortrag in unserem Grinding Solutions Forum. Ich darf Ihnen Herrn Dr. Jenkins vorstellen von der Pureon AG. Herr Dr. Jenkins wird seinen Vortrag gleich auf Englisch halten. Wir sind ja eine internationale Messe und ich denke, das trägt dem dann auch sehr gut Rechnung. Wir freuen uns auf Ihren Vortrag und ich übergebe Ihnen gleich die Bühne.
Thank you very much, Professor Burr, for the kind introduction. And I'd like to welcome everybody to this forum. I'd like to take the chance as well to say thank you to the organizers of this forum to make this happen and for the support of all the people in the background. Thank you very much. So this is a presentation, so company Pureon, and we are in the grinding world. Today I want to talk about the process of grinding specialty glasses using our Squadro fixed abrasive solution. Our vision is that we are the solution provider for high-tech materials. High-tech materials often is as well semiconductor industry, but today I'd like to talk about glass grinding. So only one slide about us, who we are. Company Pureon is a merger of two companies, of the company Microdiamond and the company Amines. Microdiamond still is main manufacturer of diamond micron powder and especially the so-called polycrystalline micron diamond powder. And we are a manufacturer of the product that I want to talk about today, which is the Squadro. Looks like this. This is a diamond grinding wheel, tile, pad, however you want to call it. Amines is a very important part of our company today because they are the ones who have all these colloidal polishing materials. Sorry. Okay, I go ahead. So these colloidal polishing materials and as well the pads, what you need as a support. We are covering many process steps. This means from cutting, sawing, wire sawing, as well grinding. We will speak about grinding today, but as well we are involved in lapping, polishing and CMP. So this is more the part of Microdiamond, former Microdiamond, and this is covered by products from former Amines. And what is very important, we may work on, because we are using diamond and all these chemicals, so we can work on basically all materials that you can imagine. Why? Because diamond is capable, because it has the hardness, but as well the chemical composition and compatibility is there. So I want to speak about the glass only, let's say, but we can work on so many other materials which we see in the semiconductor industry. But okay, let me continue. So a brief outline about what I will talk today is some little theory. You know what is grinding lapping, but I will briefly talk about it. And then about our product and how to use it under different conditions. Very interesting. And then we have some internal results that I want to show you or share with you, these two parts, and in the end to show you what is the process window of the product. So theory, grinding, you know, this is if you have a support where you have the abrasives fixed on it. Very simple. And the abrasive material can be anything like diamond or silicon carbide, aluminum oxide. It's fixed, that's important. And here for the lapping, you have loose abrasives. You can have here rigid, stiff supports as well. This is a powerful process, but the particles get stuck into the support only in situ, just interim. The polishing is a bit different, but so lapping and polishing are more close. Here you have, for example, a pad, a carrier, let's say woven pad, a Velcro, or maybe polyurethane pad that absorbs the particles, but it's again loose particles. Look a bit more closely into detail of grinding. Here you see something very important too, that our product has multiple layers of diamond, not only one. So this means we can wear it down refresh it, dress it, use it constantly. And there are two aspects that are the main important aspects. How to use it best is the downforce, of course, so specific pressure on the workpiece, and as well, of course, the circumferential speed, grinding velocity, or platen speed, and we will see there are different speeds. It's not only one speed. Let me give a brief overview of this product family. So it's not only one product, but they are dedicated to special or specific applications. So we have a Squadro O, M, OWH, H, and today we will mainly speak about the Squadro G, but what is different? So the O stands for optical industries, where we work on iron materials, softer materials, and we can use it on calcium fluoride, zinc selenide, zinc sulfide, and others, silicon, germanium. The M stands for metal. This means as well we use it for ferrous and non-ferrous materials, metals. And you see the bond, these are the same, we say standard, but it's a rather soft bond, which enables a very gentle preparation. For these materials, it's very important to not be too powerful, so to have the right level. For as well optical industry, we have a specific setup where we go a bit stronger, depends on the size of the workpiece and the setting. We can, because we are a manufacturer, we choose as well the design of the product. It can be small, large, and so fitting to the size of the workpiece, the size of the machine, diameter, and everything. The Squadro H stands for hard, because we have a very hard and powerful binder. This is for heavy-duty applications, typically for ceramics, oxides, nitrides, carbides, as well for the silicon carbide industry, but that's another story. Today we speak about Squadro G, and this has some adapted hardness. This means as well very strong and powerful, but it's adjusted typically for glass applications, so that we take into consideration what the glass type is, that it works best. And we use it, so in the market mainly we see that BK7 and quartz glass, fused silica. And what is very important here, so it's a thoughtful resin bond development. The diamond, yes, diamond has same hardness, but the resin decides the hardness of the bond, how powerful it works. You can have other bonds, you can have a vitrified bond, metal bond, and so on. This is all resin bond, but within that range you still can vary the performance. That's how our product looks like on the machine. This is a LabMaster Voltas AC400 machine in our laboratory. You see dressing stones here, and before we start, it's very important to prepare it correctly. This means dressing in the beginning, our AC400, you see here some parameters. So what do we need to do? We want to end up with a flatness, very precise for optical industry, up to 10 micron tolerance, let's say. And we do this by using aluminum oxide dressing stones, but we do it in a very, very gentle way. This is some numbers that we use. So you have different plates, upper plate, bottom plate, and the sun gear, the inner ring. 30 kilogram means very little pressure, and 2 minutes is not too long. I spoke to other people who said, oh, it's very long, but that refers to diamond wheels, because we have another product with a resin bond. But still, all these values are low. This means we gently dress and open up the product. And then we end up with a, let's say, flatness and parallelism as well in the range of, let me say 10 micron. After that, so you need to do this once to start with the product correctly. After that, you should not do it again and again, over again, because then you would wear down the product. So no. Then in between cycles, process cycles, do a gentle brushing. So just refresh it gently. That's enough. For the study now I'm coming more into techniques. That's the parameters that we use for the test. You will now see it was an AC400. We chose a grid size of 45 micron. So you have your bond, and the particles is protruded just a bit, about 20%. This means we do not have this loose abrasive, but fixed. So the protrusion is about 20%, means 8 or 10 micron that the diamond is looking out of the bond. And why? This is a level which we can get on different kinds of glasses, surface quality afterwards, that allows you to do the finishing with cerium oxide products afterwards. So that's the fine grinding where we hand over to the polishing. You see 5 values for the speeds and so on. We started, this is the starting point, the second value each, because that is, we often see this in literature as a reference or from competition products. And then we said, okay, we go one value lower, but then higher to see where we are, how we may compete with other products. So the load is little, so we do not press too hard, no, because we do not want to break the glass. Again, we work on quartz BK7. This is 2-inch wafers, short process time, and constant pressure. We have other situation here coming later. So these are the first results. This means here we work on BK7, and then on this axis you see MRR is material removal rate in micron per minute, how much we remove from the glass. And you see here we are increasing the speed, and on this axis you see the result, the surface result in terms of roughness as average, the RA value. Many people know this. So if we increase the speed, let's say it's somehow obvious, then because you have more passages over the material removal rate per minute increases. So it's nothing dramatic, but it's important. But very important, you see that the surface quality is not affected. Gets even a bit better. This means we can choose according to machine requirement and possibilities, features, we can choose the best speed, platen speed. Same here. Here we fixed platen speeds, but we say we increase the pressure. The result basically is similar, so we see an increase. The more we press, yes, we can increase removal significantly, as you see. So this is almost 9 times or something, so it's really powerful. But again, the RA value here is almost constant, so the axis here is a bit different, but the result for both is about 0.35 micron, and again, that is the level from which you can continue to chemical polishing. The very same is true if we use quartz, and basically we find this on all other materials that we use. If you go on a silicon carbide or other or ceramic, we see the same. This means increasing speed, we increase linearly almost the removal rate while keeping really constant the surface quality. Same here with the pressure. So this, and on quartz, because it's harder material than what we had before the BK7, this means the absolute value of RA is just on another level, means finer, because you dig less deep into the material. You might say, okay, you can do this once, but I have mass production. Yes, very important. It's for mass production. So how can we repeat it? Can we be sure that we do that? If you have a grinding tool, you have your chips, you're talking about as well, about breaking the chip, and you have that swarf that fills up the product. So we have protrusion of the diamond, and we load the product with swarf. We need to really keep it open, and this can be done by choice of appropriate platen speeds and parameters, but you need a specific pressure, a certain level of pressure to break the chip, as you said before, to speak just before, as you mentioned. That is very important, so that you keep it open, you keep it running, you keep it going. And this one is a very, very clever system. Here we used, again, an AC from Labmaster Walters, AC700F. And this one now does not apply constant pressure, but constant platen feed. This means it moves forward and removes as you set it. And the thing is, you want to, let's say for mass production, you want to always have the same time. So what the machine does, it regulates pressure. So it alters the pressure. So you break the chip and then release a bit. And so over time, pressure of the machine or the load increases a bit. That is as well due to the wear of the product as such. There is some wear, sure. But like this, we can always have the very linear, so it was set to 200 micron per minute removal and on a fixed time. So each cycle takes the same time. I think it was 120 seconds. Yeah, so you can, like this, set process time and removal rate. So now these are some internal results. Why we are showing this to show what are the capabilities, what we can do. So internally we asked us what would happen. So do you see Squadro G, Squadro G, Squadro G? So same product, but no, we have different concentrations. Do you think, okay, more diamond, yes, can help, or is difficult to really make it work? What does it do? Depending on material and parameters. So if we increase speed and we have more diamonds, so the A has low diamond concentration, B medium diamond concentration, C high diamond concentration. All the same results. Again here, the RA value does not alter. That's very important. But so whatever we do here, no change. But if we move to this slide, if we increase pressure, then you see a big difference. And from here to here, you can almost double the performance. Why? How can we understand this? It means if you have more particles, more specific pressure on the workpiece, you need to have the appropriate specific pressure. This means if you want to make use or benefit of this high diamond concentration, you need to be capable to apply that pressure. Otherwise it doesn't make sense. But we are capable to do so. Another very important thing is the lubricant. I was mentioning swarf and keep the product open. I said we need to have protrusion of the diamond, but the product gets loaded by swarf, so we need to remove it. So here we speak about surface tension, how to wet, so to not that the swarf gets clogged or clustered. So we started with this one is a pale line, is a specific lubricant, but the performance is low. During our developments, we could create a new lubricant that very much fits to the product, and the other two lines are competition products. So there's a big gap. So the lubricant with all the parameters is very important. We see as well here that we could significantly improve. This means you need to have a combination of the grinding product and the lubricant. Same here again on the quartz. We see that we see that the new lubricant fits much better. And just to mention again, the surface quality never alters because the product is very consistent, very stable. Same here. Yeah, okay, I continue. Now, how do we position ourselves in respect to the competition? We have a material removal rate on competition product, and in respect to different parameters. This one. So this one. The black line is the removal rate of a competition product. You might say we are cheating. No, we do not. This product remains very consistent over the rotation speed, while as we said, have seen before, we increase. This product is designed in a different way. Many people of you know this probably. So you can have a product with protrusion or one that is designed in a different way. I do not say more about this, but that is a very well-known product in the market. Stupid. So where you cannot alter, only if you apply pressure, it moves a bit, while we can have that increase. It's even more dramatic, next slide, where this becomes less because it's not open. So, but not speaking about competition, but about our product, so we can increase the performance, while with other products it's a bit different. So our product is a new solution in the market so that you can benefit from that new approach. So already a summary. So we have seen different Squadro products. The Squadro G now positions itself well in the market. So as a complementary product in respect to ceramic grinding, metal grinding, and so on. And I didn't mention that too much into detail, but we have it in many grid sizes. Depending on the glass type, we have seen tests with the 45 micron and the 30 micron, but we have other grid sizes so that you can choose the level of your performance. Instantly, this means because we have the production, the product starts to work and you get your surface quality right away. And if you continue grinding, you just wear down, but your surface quality is always the same. And that is, the productivity can be tuned, as I tried to outline. So choosing the parameters depending on the friability of the workpieces, you need to throttle the process maybe a bit, but you will always see a good process window, and it's a very broad process window. And if there's any question, we are ready to support you to apply the product in the best way. Thank you very much for your attention. And for questions, please come to us. We are in hall 7D30. Thank you very much.
Yeah, thank you very much. I think we can stay in English.
Sure.
We started with English. Are there any questions from the audience? Seems not to be the case, but I have some questions. First question I have, is this technology, are these grinding pads applicable at each lapping machine, conventional lapping machine, or is there any modification necessary?
So we try to be independent. So we have good collaborations with many partners, but it should be independent so that it can go anywhere. And it's the technology, let us be frank, it's rather simple, but very efficient, because we want to be able that we can sell it anywhere in any market. Yes, so it's very easy to apply.
Okay, thank you. So another question would be, you have been talking about the polishing or grinding of glass, especially hard glass material. Yes. Do you have also experiences with other materials, other brittle materials or even ductile materials?
Yes, we do, of course. But there is, in respect to glass types, so many different versions that it's more difficult to work on the softer types because you can easily break them. And then we are reducing particle size, maybe reducing speed, limiting the process a bit, not affecting the material too much. But in the beginning I said, yes, we can work on any material because the diamond allows it, but it's the setting the process in the right way, not overshoot. That is very important.
Right, and maybe another question. You have said that the process becomes very predictable with
Yes.
your technology.
Yes.
So is it really the case that you can, how can I say, give such good prognosis that you come to first part, good part when you start with your technology, or?
Still, it's a combination of many aspects. So the size of the workpieces, customers have another machine, maybe edge chipping, there's something, which lubricant is on site. Often we can bring our lubricant, sometimes not. And you need to really still find your process window. It's not that easy. That is why it needs the support from the technicians.
Okay. And well, maybe one next
Sure.
question,
Sure.
if I'm allowed to. I think at the moment it is a very important factor to save resources, to save energy and so on, so to think about the environment. And I can imagine that your technology could contribute to a less large CO2 footprint of production. Is it true, or?
A good question. Of course, we did not calculate it, but yes, if you increase efficiency, you save process time, means energy on the machine. We are very cautious on the lubricants as well, the chemistry, not using oils, but environmentally friendly lubricants, things that you can easily dispose and things. So it's, yes, we care about industry or environment. This means the energy, yes, we do so, but to calculate is difficult. But if you reduce time significantly, yes, you save just the electric energy.
Time and also wear and also additional fluent supply,
Yeah.
for instance, and so on.
Yeah.
Okay, are there any questions from the audience? No questions, so I thank you very much again.
It was my
Vielen
pleasure.
herzlichen
Thank
Dank
you.
nochmal.